In this lesson I'm going to be looking at revising fractions. So at the top here I have a whole thing. I'm going to pretend it's a cake and it's something that we can cut up into pieces. So in this cake here the dots are just there to help guide us when we're cutting it up. Now if I cut it up into two equal pieces I have a half, and that's because the orange represents the part I keep and there are two parts. So one out of the two parts is a half. In the next cake, I've cut it up into 6 pieces and I have 3/6. You notice it's the same amount of cake as in the half cake. Those two are equivalent fractions. In the next cake, I've cut it up into 12 pieces and we have 6 of them, 6 of the 12. So that's 6/12. Again, that's the same as half the cake. You would be eating the same amount. And in the last cake, I've cut it up into 4 pieces and we've got 2 of them, 2/4. So all these fractions are actually the same amount of cake. So if they're all the same, how do we change between them? How do we see that they're the same? Well, let's start off with 3/6. If I divide 3 by 3, I get 1. If I divide 3 by 3, I get 2. That means it's the same as a half. I divided both the top and bottom, numerator and denominator, I divided them both by the same number, 3. And I ended up with a half. I can do the same thing with 6/12. Let's divide 6 and 12 by 6. So 6 divided by 6 is 1, 6 divided by 12 is 2. Again, that's a half. You can also go the other way by multiplying. So if I was to take the half over here and multiply 1 by 2 and 2 by 2, I'll get 2/4. So to change fractions from one equivalent fraction to another, you just need to do the same to the top numerator and the bottom denominator. Multiply by the same on the top and the bottom, or divide by the same number on the top and the bottom. So now I'm going to look at adding fractions. So let's have a look at the first part at the top of the page. I've got 2 cakes. One's representing a half and the other one's representing a quarter. So that would be a half plus a quarter. Now the problem is both of the pieces are different sizes. You can't add fractions if the pieces are different sizes. They need to be the same size. What we need to do is actually change one or both of the fractions to be the same size pieces. So we try to think of a number that the denominator is going to. That is, a number that the 2 and the 4 both go into. And the lowest common denominator is always the best one to use, although it's not essential. So let's look at 2 and 4. The smallest number that they both go into is 4. So that means I can keep the quarter because that's already in quarters. With the 2, I need to change it into quarters. If I double both the numbers, multiply the 1 and the 2 by 2, I get 2/4. When you look at the bottom diagram, you can see that the pieces that we're adding together, for the 2/4 and the 1/4, are now the same size, and we can add them together just by adding the 2 and the 1 on the top and getting 3. You don't add the bottom numbers. The bottom numbers are telling us how big the sizes are. You just add the numerators, the top numbers. Subtraction works the same way as addition except that you subtract the numbers. So in my example here I've got 3/4 and I want to take away a half. We can turn a half into 2/4 by multiplying both of them, the numbers in the half, by 2. And that gives us the new equation of 3/4 minus 2/4. So now instead of adding the 2 numerators or top numbers, we subtract 3, take away 2, and we get 1/4. And you can see from the picture that if I had 3/4 to start off with, and I took away 2 of them, there'd only be 1 left. So the answer is 1/4. When multiplying fractions, what we're really doing is getting a fraction of a fraction. So in this example here, I've got a half multiplied by a third. That's the same as a half of a third. So I'm trying to split the third up into half of what it is. So let's have a look at the picture. If I do a half of this third, I'm actually looking for this section here, which I've highlighted with the pink colour. That's the same as what I've shown on the right. Now, over on the right, that's actually a sixth. So how do we actually work it out with numbers to get the right answer? Well, with multiplication, you just multiply the numbers on the top, the numerators, together. So 1 times 1 is 1, and on the bottom, you actually multiply the numbers together and get 2 3s are 6. In addition and subtraction, we didn't touch the bottom numbers. We didn't add them together or subtract them. But in multiplying, you do multiply the two bottom numbers because we need to get an answer that matches what makes sense from the diagrams. It's difficult to understand how division of fractions works, but it's not all that hard to actually do. But let's have a go at it anyway. In the example, I've got 3/12, and I'm going to divide it by 3. Now, to turn 3 into a fraction, I have to write 3 over 1. If you think about it, 3/12, if I split that up into 3 pieces, each piece is going to be 1/12. So the answer needs to be 1/12. To work out the answer, we write 3/12 and we multiply it by 1/3. Now you notice I've swapped the divide and the multiply and I've flipped the fraction. These two things in effect cancel each other out and I will get the same answer dividing by 3 as I would multiplying by 1/3. So let's multiply by 1/3. Multiply the two numerators, the 1 and the 3, and 3 times 1 is 3. Multiply the two denominators, 12 by 3, and I get 36. We can cancel that down by dividing both of those numbers by 3. 3 divided by 3 is 1. 36 divided by 3 is 12, so I get 1/12, which is the answer we wanted. So to divide, flip the fraction upside down and multiply. A fraction is a part of something. In this example here, I've got, over on the right, 1/4 of a cake. But I've also got 2 whole cakes. We write that as 2 and 1/4. Now if you were to count up all the quarters that I've highlighted in green, you will see that that's also the same as 9/4. The number on the left is called a mixed number. And that's because it has a whole number part and a fraction part. The number on the right is called an improper fraction. It's improper because the number on the top, the numerator, is bigger than the denominator. The mixed number on the left has 2, which really means 8/4 because each whole cake has 4/4 and we've got 2 of them. And you can easily work that out by going 2 times 4. And there's one more spare quarter. So to change a mixed number into an improper fraction, we just say 2 times 4 plus 1 is 9, and we have 9/4. So that means we just say 2 times 4 plus 1, which means we've got 9/4. When we're going the other way, we divide 4 into 9. So I'd say 9 divided by 4 is 2 times, because that's 8, and there's 1 left over. So we write 2 and 1/4. Let's just do another quick couple of examples. If I have 3 and 1/3, I would say 3 times 3 is 9 plus 1 is 10/3. Going back the other way, 10/3, 10 divided by 3 is 3, and there is 1 left over, 1/3 left over. So mixed numbers and improper fractions are just two different ways of writing the same thing. In maths, we like to have the simplest version of the fraction. So for example, if my answer was 3/6, we'd cancel that down into a half, And we do that by dividing by 3 into both of those two numbers that are in the 3/6. 3 into 3 goes 1, 3 into 6 goes 2. Now you don't have to wait until you've got your final answer to do cancelling, and in some cases it's easier to do it sooner. If you're multiplying fractions, so 3/12 multiplied by 4/8, you can actually cancel any number on the top, any numerator, with any denominator. So I could cancel 3 and 12, or I could cancel with 4 and 8, or I could cancel with 4 and 12. You cannot cancel 3 and 4 because they're both numerators. You cannot cancel 12 and 8 because they're both denominators. I'm going to work this sum out by cancelling early and cancelling late, so you can see the effect of both. So if I multiply first and then cancel, I'll get 3 4s are 12, 12 8s are 96, 12 goes into 12 once, 12 goes into 96 8, so I get 1/8. If I was going to cancel early, I could say 4 goes into 4 once, 4 goes into 12 3, 3 goes into 3 once, 3 goes into 3 once, so I end up with 1 times 1 on the numerators, 1, and in the denominators, 1 times 8 is 8. So you can see either way I get the same answer. I generally prefer to cancel early myself because the numbers are smaller and I don't need to know as many tables as I do when I cancel late. But they give the same answer.